Hey boys and girls, it's Miss Holmes and Miss Attville, and today is your second flip video lesson. In this lesson, we're going to learn about the relationship between digits and their place value, and we're also going to look at expanded form versus expanded notation.
Okay, so here we've been talking about decomposing and composing numbers, and we've been talking about the relationship between each place value. So if you'll look to the right, we have our ones or our units, and we know it takes 10 ones to equal 110. That's our arrow showing us that. And we also know that it takes 10 tens to equal 1 flat or 100. It takes 10 hundreds to equal
1,000. It takes 10 thousands to equal 1 10,000s. And then it takes 10 10,000s to equal 1 100,000s. So what has stayed the same is that relationship 10. The 10, we keep saying, it takes 10, it takes 10, it takes 10 to move to the next place value. So here we took our pictorial and we showed you the relationship again. It takes 10 ones to equal 110. That's what this 10 is representing. It takes 10 tens to make 100. So guys, each time it is moving to our left, it is getting 10 times bigger. If we had 10 tens, it's the same thing as 100, so we would put it in the hundreds place. So that is showing the relationship. Why keep 10 tens when I can trade it for 1 100? So each time it moves to the left, we're getting
greater.
10 times greater. Here, we decided just to show you by values.
Yes. So if we have 5 ones, we know that the value of that is 5. But if you'll look to the next column to the left, if I have 5 tens, we know the value of that is 50. So we can say that 50 is exactly 10 times greater than 5 ones.
So if we had our 5 tens, and we move it over here, would it still be 50?
No, it would not be 50.
Because it's getting 10 times bigger?
Correct.
So we're saying 50 times 10 would get me 500. And since we're saying hundreds, we're putting it in our hundreds?
Correct.
So every time it's moving to the left, Miss Attville, we can honestly say it's getting 10 times bigger?
Yes.
Okay. So here, this is, we've taken a place value chart and we labeled our periods. And we're going to look at these values right here of the twos. So we're going to look at the relationship between these two. And the reason why we're going to look at these two digits right here is because they're exactly the same. To be exactly the same is where your 10 times bigger plays a big part. So one way that we can show the relationship between these two digits is to say, here's my equation. We're going to do it by an equation. That we are getting our, I'm getting messed up, Miss Attville.
Well, if we have 200s, that has a value of 200. But as we move to the left, because the 2 is exactly the same digit, then we can say that 2,000 is exactly 10 times bigger than the digit in the hundreds place.
So we're looking at the value, not just the digit. So our 100 this is the value of 200, which is represented here.
Right.
To go to the next place value of 1,000, I'm getting 10 times bigger.
Yes.
And then I get 2,000.
Yes.
So another way we could say that is saying that the digit in the thousands place, here's our digit in the thousands place. We can say it is 10 times bigger than our hundreds.
Because they're exactly the same digit.
So thousands we know are bigger than hundreds, but we can say it's exactly 10 times because the digit remains the same. They're both twos. So on this in your Math IMB, we want you to go ahead and label, here's your title, also put it in your table of contents. We want you to copy this chart, label the periods, and then place the comma where it needs to go. And then we want you to underline the digit that shows the relationship of getting 10 times bigger. Now remember, on the first slide, we just showed you an example of the relationship. And we talked about how in order for it to be exactly 10 times bigger, the digits need to remain the same. So guys, when you're down here writing your equation, it's okay to flip back to the slide before to review and look how we showed you.
Okay, so now we're going to look at the difference between expanded form, which you guys are pros at because you did a lot of that last year. We've done a quick review this year, and we're going to go to expanded notation. So expanded form is, remember, it's showing us the value of each place. So we have 600 blocks there, but we know that that represents a value of 600. We have 3 tens, but that represents a value of 30, not 3. And then we have 0 ones. So we know that what we're representing here is 630. That's expanded form. Now, expanded notation, Mrs. Holmes, is different.
We're showing each digit multiplied by its place. So you notice this is a pictorial model. We have 1,000 cubes. So we represent that by putting a 1. We have 1,000 cube, and we multiply it by that's value. So this is worth 1,000.
Okay.
Here we have how many flats?
We have 3 flats.
So we represent the digit as a 3 to show we have 3 of those. And the value of 1 flat is how much?
100.
So we have 3 flats times its value of 100. Here we have how many tens?
6 tens.
We represent that with the digit, and we multiply it by 10 because the value of this is 10. And then we have
2 ones.
represented by the digit 2. And we multiplied it by 1 because that 1 unit is worth 1. So here we've given you a pictorial model, and we want you to attempt to do expanded form. It's always okay to rewind and look at the slide before.
Expanded form or expanded notation?
I'm so sorry, expanded notation. We want you to use the expanded notation. So again, we want you to count, use the digit to represent the amount of blocks, the amount of flats, the amount of tens, and the amount of units. And we're going to multiply those by its value. You guys flip back if you need to look at the definition and the examples. And then here, same thing, but this is in standard form.
Mm-hmm.
We're going to take, which we can start at either end, Ms. Appa. We can start in our ones place or we can start in our 10,000s place.
Okay.
Which one do you want to start at?
Let's start at the ones.
The ones. So the digit that is representing our ones is, in this case,
1.
1. So here's our digit, and we're multiplying it by its value. So how much is the ones place worth?
1.
1. So that's where our 1 comes from. We move to our tens place, and the digit in our tens place is
8.
And we multiply, by 10. Sorry, guys. By 10, because that's how much this place is worth.
Okay.
We move to our hundreds.
We have 3 hundreds, and the value of each 100 is 100. So we multiply 3 times 100.
We move to our thousands place. The digit in our thousands place is a 6.
Mm-hmm.
We multiplied it by 1,000 because that's how much the thousands place is worth.
And then the 7, of course, is what we put first. And then we multiply that by 10,000 because that's how much that place value is worth, 10,000.
And so remember that each digit is multiplied by its matching place value. So we want you guys in your Math IMB same page. So all this that we've asked you to do in your Math IMB under that title should all fit on one page. You can skip a few lines to space it, but make sure it's all on one page. And we want you also to try the expanded notation with this standard form number. And we will see you guys tomorrow. Have a great evening.